Can you all hear me? Perfect. Great. Thanks a lot for this invitation to come here and present. My name is Vinay. I run this company in Copenhagen called Leapcraft. But today I'm going to talk about a slightly different approach that we have to data. I'm trained as a designer. I'm not a tech industry person by definition. I slowly drifted into the tech industry. I built some software, did a couple of startups, built a design institute along the way. And I want to transpose our mindset today as a different type of raw material that we're having. And I want to take you back in history initially. In 1907, there was something really unusual that happened. And since I have this little designer side of me still in my DNA, I'm super fascinated by materials. Material science is something that's like been deeply engrossing for me. So in 1907, there was a Belgian-American chemist who basically synthesized the world's first plastic, which was Bakelite, basically. This is an interesting moment because before this, if you made a product, a physical product, it had to originate itself in the raw material sense in some natural resource. Traditionally, it would be wood, metal. It could be other forms, leather. And it was super fascinating because this led to an explosion of totally new types of products in the market. It was pretty radical for its time. And it allowed product manufacturers and designers to come up with totally new products which didn't exist before. It allowed giving form and giving shape to things in ways that no one had seen before. A small example of that is this Ericsson phone. It was the world's first unibody design. And this is pretty old, too. It's around that time, in the 20s. Before that, it was made of metal die cast. So they would cast like huge amounts of metal, or they would make a wooden box and then hang it up on the wall. This radically changed behavior. And it was well thought through in so many ways. First of all, you could lift a cradle, and that was light enough that you could actually put it on your shoulder, which is pretty interesting. You also had the ability to grab the whole device in one hand and lift it and move it around. So they even had a little recess in the back where you could put your hand inside and move it around. It became iconic for its time. And ever since then, so iconic that you see that symbol even today in your phones, right? So the question becomes, what kind of tectonic shifts like that actually influence our market, influence our decision-making, influence new products and new technology? Right? And I believe that for the creative world, there is a new infusion of this happening. And for the scientific world, also this is an interesting paradigm to believe in. So at least our perception of this new material that will drive totally new types of innovation is not tangible anymore. It's intangible, of course, and it is data in all forms, shapes, and sizes. So you can pick your size, big, small, medium, whatever you want to. Whichever buzzword you want to belong to, you can pick that. But the key thing that's happening is that this raw material is shaping our perception, it's shaping the way we build businesses, it's shaping the way we ask questions, and it's influencing society in ways that we've never seen before. So I just want to show you some cases because I love building stuff and I like to play with raw materials, and this is one of those, of course. But before that, just 2 words about what we do. So we basically bring a user-centered design approach to basically using data in all sorts of ways. So whether it's in the traditional software sense or totally radically new product development, which some companies seem to be more willing to embrace and some less. I'll also show you some glamorous failures because I think that's also important for us to recognize that sometimes things don't always work out. Anyway, the 3 things that we mix together is design, because we want to bring a humanistic, user-centered approach that includes excellent user interfaces and interactions and stuff like that into new technology development. Data, clearly, all of us recognize this now. Of course, we have a small team that sort of literally lives in the cloud. We build all kinds of services on the cloud. We enable data-driven products to happen. That includes orchestrating complex infrastructure and stuff like that. And then the science part is interesting because we bring in a lot of core mathematics,
interesting sensor development, not so fancy as the flying machines, but more humble, more simple approaches sometimes to simplify everyday life. And I will have to specially emphasize the whole role of signal processing, because hardware is really hard sometimes because you are physically restrained in so many ways, unlike the cloud, which seems to be ever growing and expanding. So these three things come together, and we start doing some unusual things with it. So I will start with a series of stories. The initial stories are more pragmatic, more business-driven, and then it gets wilder and wilder as we move in. And so let's jump straight in. This is an interesting example. This is something that we executed recently for an enormous shipping company out of Japan. Somehow we've had this legacy of working with shipping companies, and it's just coincidence. NYK Line is a big carrier of cars. They move cars around the world. They move iron ore. They move LNG. And there's one thing that's supremely important for them. Certain types of goods need to be on time, exactly on time somewhere. And certain types of goods, like iron ore, it doesn't matter if you're a couple of days late, but the fuel consumption is so enormous that optimizing it by the minute is so important for them. As in, like, you could spend $100,000 more by just oversteaming by a few knots. So it's an interesting problem. And they came to us and they said, what can we do with this? And we said, OK, let's look at the operator, that is the land side. Let's look at the ocean side, that is the voyage and the ship and the captain involved in the engine room. And we basically did an interesting analysis. And we, of course, everyone was talking about sensors, IoT, whatever. And we had to sensorize the ships. And that's one of the first things that happened was these guys at the shipping company, they decided to embark on a pretty complex sensorizing project. And then the data started dripping in, and then suddenly started opening up, and then there was a floodgate, of course. And then how do you manage a floodgate of data that comes out of a ship? And how do you make sense of it? And how do you transpose that into something meaningful eventually is the big question. So the usual story, we built some apps, of course, like everyone else. We did some basic tools that allowed streaming data to come from the ships. That includes some legacy systems. There's this classic thing called the noon report. I don't know if you've ever been in the shipping business, but there's still faxes flying around from ships today. We integrate manual systems and automated systems, and we build a story. We built a comprehensive inside story for both the vessel and the land side to coordinate, cooperate, and build systems. But what's even more interesting is that there's a lot of optimization algorithms that are being built now. Fuel efficiency and economy is the single biggest factor. Of course, bunker consumption, as it's often called, is a big focus on this stuff. And we did some nifty things in that space where we actually did some classic supervised learning type stories. And we tried to build a business case out of this. And it's super interesting for us because this is one of the most fascinating straight line business cases. Save money, do better, get people and goods on time. So this is a very simple case in that respect. Of course, you bring in a digital element, and it can be made sexy. And then it grew into big dashboards and systems that sort of were deployed on enterprise level and stuff like that. Here's another very different story, completely different story. We got approached by Philips, the big appliance company, and we started discussing with them some of the core issues that they were facing. And this is not a classic story of product marketing or knowing how to sell better and stuff like that. This was a real hard engineering problem that they had. Philips makes millions of these shavers, literally, around the world. They sell them. The problem with these kinds of devices is that they're personal grooming devices, as they're called, and they are made on assumptions. They're based on assumptions about how people behave. They're based on assumptions about how people use them. And the classic market studies give interviews and hundreds of surveys, literally thousands of surveys sometimes. They spend enormous amounts of money in doing all this. And still, there's a high product failure. There's a rate of return which is very problematic. And they never seem to get the market product fit perfectly in balance. So we discussed this with them, and we said, how about we sensorize the shavers? We deploy a few in some strategic markets, not as a mainstream product that you sell in the shops, but more as probes in the market that people basically acknowledge and comply to. So as in, the respondents basically sign a piece of paper saying that it's OK to collect data from your shaver, and then do stuff with it. And the question becomes, what can you do with it? And this is where the story becomes really interesting. So we thought we were building for something. We thought we were going to help them understand the market better and know which type of customer uses what, all that stuff. And there's some fantastic anecdotes in that. Of course, we did that. And it was interesting because one of the most fascinating deployments we did was in China. And from the data, we discovered some deep insights which no one knew before. So basically, each of these sensors were attached to inside the shaver, so there was no difference in the form factor. We had a wireless link that backhauled all this data to our cloud infrastructure, and then Chinese firewall. Yes, we actually realized that there was a real Chinese firewall. And something else happened, which we didn't ever anticipate. First of all, we could, of course, do all the classic things like understand how long people use them, how much they charge them, all that kind of traditional stuff. But then we realized that something really strange was happening. Almost every time, our sensor systems were getting reset magically. And we couldn't understand what was this. And then we started investigating deeper and deeper in this. We started looking for signal patterns, and then we started making interviews to find out what happened. And we realized that a lot of people in China actually switch off the mains in their homes when they leave home. It's a bit like a hotel key type strategy, you know. You pull out this thing, and then everything is safe inside. And that means the implication was not just on a silly shaver somewhere, microwaves, fridges, you name it, like everything got reset. It was a bit of a shock for everyone. Anyways, so that was one outcome. There were some good outcomes also. We managed to optimize the battery, capacity. You know, there's all these arguments inside, whether it should be actually 700 milliamp hours or actually should be 500 milliamp hours. And it's a big story for them because you shave off 20 cents off a battery, and that translates into some significant numbers for them. So we had some other types of business cases that evolved that we didn't even anticipate. So data sometimes can become this active currency in the system. And I say active because it can be traded in all sorts of ways, not so fancy like the Saxo Bank system, but it becomes an interesting product that can be traded inside an organization. And that creates both good and bad things. The good thing is, of course, excitement, lots of interesting opportunities. The bad thing is that when things don't look as they're supposed to look, the blame game starts, and there's transparency in the system suddenly. So that has a peculiar effect. I won't go too deep in that. Then comes another type of story. This is something very different. This is something that we did for a medical use case. You know, in Denmark, we're surrounded by pharma and medtech companies, so you can't escape this business. And so this is an interesting but rather sad story. This is a story about cancer. And we've been working on an oncology strategy for a particular use case. And there's a lot of data that's collected all over the world on all these cases. Most of it comes in boring rows and columns, and thankfully it's structured, so this means that we can actually work with it directly. And this is an example of some data set that a public foundation in Germany collects on all the cancer patients in Germany. And it's impossible to make sense of this stuff. And how do you apply that to research? How do you apply that to strategy inside companies? What product development implications are there for you downstream? These are all interesting questions to ask. So we did a piece of analysis where we used some existing data and some existing tools. We didn't reinvent anything much, actually. Unlike the shipping story where we invented everything from scratch, we just took what was available and we just presented it in a new way. And it opened up eyes in new ways completely. So here's a small outcome of that process. This tool was actually built by Oliver Zimmet, and we found it online, and then we played around with it, and we optimized it, and we built on top of it. And it's interesting because this is what's called as a Sankey diagram that explains age segmentation of people affected with cancer. This is the gender, so whether it's men or women. And this is where in the body does it really affect you, so the localization. So whether it's different parts of your body. And then at a given cutoff point, whether there was a person who was dead or they survived. Sorry, it's a bit morbid, but I thought it was a valuable case to discuss. So let's look at women first. The predominant case is, of course, breast cancer, followed by other forms, like including bowel cancer and lung cancer. And this is a global phenomenon. This is, of course, data from one particular geography. But luckily, with things like breast cancer, there is a higher chance of survival because you can sort of work on it with multiple strategies. So you can go chemotherapy, surgeries, all kinds of combination strategies that can be applied. There are some types of carcinogens and cancers which are really difficult to detect. So this is what happens to women. With men, it's mostly prostate cancer followed by lung cancer. And lung cancer, you might guess, is mostly driven by smoking. And then we try to look at data patterns in tobacco sales in Germany. And it kind of reinforced the story. So we could understand, like, at least there's some sense in that. Actually, in Denmark, it's the contrary. Women smoke more than men do currently. It's an unusual trend that's picking up. If you look at the number of people who died, most of them died from lung cancer. And then we discovered that the complexity in the data is actually much deeper, because lung cancer is just what's written on the death certificate. Usually lung cancer manifests itself as a series of other things that happen and finally accumulate in the lungs. So if you really want to get deep into the story, you need to start looking at correlational data. You need to understand the true causation behind it, and that becomes immensely complex. But what this already did was that it allowed people to see what kind of strategy need to be applied, both therapy-wise but also research-wise. Where should you focus your money? Where should you focus your time and effort? These kinds of critical questions start coming up. And this is why storytelling is supremely important. And storytelling with data becomes even more interesting, because you can actually enforce your story with facts rather than assumptions or opinions. Lung cancer, unfortunately, has a 50-50 chance. It can go both ways. It's very, very difficult to treat. Anyways, I won't dwell on too many morbid stories. Let's move on. This is an exotic story now. This is a classic story where we thought, come on, Denmark, everyone loves good design. Everyone is overindulgent in furniture and lamps. People spend huge amounts of money on this stuff. And every design student wants to be a furniture designer. So there must be an interesting space to do something. And we worked with a classic traditional furniture company called Fritz Hansen. They make beautiful furniture, legacy, Arne Jacobsen type licensed furniture. But then how do you move on to the next paradigm? Where can you use new materials, new creativity, new methods to actually drive new types of furniture? So we started discussing with them. And we started doing a really amazing exploratory process with them. And it's a both good and bad story, because it is an outstanding story of how data science can meet material technology to create new things. The unfortunate part is the organizational part, which I'll come to later. So what we did was we started building scripting methods. So basically, we started working with different types of optimization algorithms to build new product surfaces and volumes, because furniture has to be given form, it has functionality, and it's a balance between manufacturing cost and aesthetics. So what we started doing was that we said, let's work with some materials. Let's work with aluminum, for example, which was their favorite material. Let's work with wood and see how new processes can influence this. And we started working on these basically different types of algorithmic approach to applying additive manufacturing, subtractive manufacturing, different techniques to come up with totally new ways to build furniture. And that became really fascinating. And out came some surprising outcomes. We built this little aluminum thing, which was meant to be like a low stool or like a coffee table sort of thing. It is all produced with a metal 3D printer. And what's interesting is that it is about 1/50th the weight of a traditional metal cast object. And it had some unusual properties. One of them was that you could basically proposition this as a cube that you will sell in the store, and then it'll get smelted into a product that was much bigger in size. So this is the marketing stunt that we try to approach, where you would walk into a store and you would go pick up a metal cube, like about this size, and say, I want a bar stool. And that would transform itself into a bar stool, and then you would get this memento to show off in your showcase at home, because over the next cocktail party, that's what you want to do. It was a fascinating story. I think it would have met some reasonable success. Then we got a little practical. So they make all these beautiful tables and amazing chairs and stuff like that. We started designing some interesting new products for them, where we said, let's take some traditional things like office furniture and see how we can optimize this product. So let's look at engineering and design where it meets. One of the things was most office tables, especially the meeting room tables, they have a complex need for taking a lot of load, and they usually have metal legs, and they have pretty heavy bases and stuff like that. That's a transportation problem. There's lots of complexity in damages because packing becomes immense. So we applied the same strategy, and we started building foamed aluminum parts for making all the fixtures. So what happened was we started building like low-profile aluminum fittings for the product, which are mostly hollow inside. I should have brought one of those. It's pretty fascinating because you can just stand on it and it weighs nothing. It's like, so it is pretty interesting to look at this kind of furniture transition that might happen. So we went through quite a lot of product development iterations in this. But I think what's worth recognizing here is that a good process and a good idea or some new material science or new data-driven processes alone is not enough to shift markets. We did some initial testing, validation, all that stuff. Technically, we could prove a lot of stuff, but the business case was not sticky. And of course, there was some organizational complexity. Typical mid-sized business, decision-making loops are a little bit fragmented and very steep pyramids. So the product and R&D and the design team wanted to work very much on this, but decision-making didn't exactly go that way. So unless you empower people to do stuff that can actually shift your market for you, it is very hard. And I think we heard this earlier this morning too. Here's another very unusual, not so successful story. So I've shown you some successful stories that are straight line business cases. You know, we make money on that, like that's our bread and butter. And then we lose money on stuff like this once in a while. But we still thrive and we still enjoy doing new products, totally new stuff. Denmark also has this unusual cluster of audio companies, including a lot of hearing aid companies. And Videx is an interesting example. We proposed a very radical solution to one very complex problem that hearing aid manufacturers have. Every hearing aid that you buy can come in two forms. One is a generic fit and a very custom fit. The custom fit things are extremely expensive, and most of the world cannot afford it, and most taxpayers cannot support that process. But the generic ones are kind of crappy and they're not that elegant and they don't fit perfectly. And it's an interesting optimization problem. So the question is, which kind of generic product in hearing aid can fit a vast majority of people for a given population? That's a good business question to ask. Because if we can generalize to that extent, I know generalization is not a good word today, but if we can generalize to some extent, there is a higher business case there. So what we did was that we realized that, and this opportunity came because what they do is that they do make custom hearing aids and they scan people's inner ears with a 3D scanner. And they collect full 3D scan of the inner cavity of your ear, and then they make custom hearing aids for people who can afford it. So it's extremely expensive, very well-fitting, top-notch audio processing, and all that stuff. But what do you do with 3D scans from 5,000 inner ears, apart from making a custom fit? So here the data becomes a byproduct. No one literally was getting discarded because once you had the CNC machining process, the thing was of no use anymore. So we said, let's go take a look at this data. Let's try to do something interesting. And that's when we started exploring this idea. And something very fascinating emerged from that. And it's a symbiotic process because we work very deeply with their product development people. And one interesting fit that we discovered was that we could basically optimize the general or the generic products that we manufacture to actually fit a very large population set by taking the 3D data and building basically fitting algorithms. So in the container shipping industry, because we did some cases like that, where the classic problem of how to stack containers and how to fit as much goods as possible into a container was an interesting business question all the time. So let's apply that to this and see if we can optimize the parts of the hearing aid, which are really small, amazing little components, and optimize it in a 3D profile in such a way that we know what shape and size the parts should be, so that they can be configured for a fit that will fit a certain type of population. It will fit, say, male years between 60 and 70 in North America, or female years between 40 and 60 in China, these specific niches. we thought this will actually fly as a business case because it's a fundamental issue for the company. But again, the roadblock or the showstopper here was that we couldn't prove the efficacy of this whole system on a large-scale business case on a global production level. And that means that product R&D was hungry for stuff like this, but there was kind of a difference in culture between how decision-making was happening inside the organization. And that's a classic thing. We have seen so many of those cases by now. But anyway, I show this because it was a failure. We didn't do it, but it's an interesting opportunity. I want to shift the focus to something very different now. I originally come from India, lived and worked in many countries for the last 10 years in Denmark. I even lived in Nigeria as a small kid, lived in the States, lived in Italy. Healthcare is a very basic thing, which you can optimize and strive to be better and better, and there's the high-tech world of that, and then there's the extreme low-tech world also. So a couple of years ago, I initiated this idea of frugal digital, as in like build high low-tech strategy for solving some really fundamental healthcare issues, especially in developed countries. And one of the most interesting pieces of work that we've done is looking at the data gap in the healthcare infrastructure, especially in India and Southeast Asia, but also in some other African countries, and try to fit that gap through simple interventions. And simple as in simple is hard to achieve in many places. So this is an interesting story of what happens with maternal healthcare in India. Asha worker, she is a typical government employee who goes door to door for expectant mothers and families to basically understand what their needs are and try to help them with their childbirth process. And typically the problem is that the Asha worker becomes the bridge between the patient and the public healthcare system, and there is quite a lot of physical distance between the two. The Asha worker is local, the local, what's called as the public health center is typically a good distance. You don't want to walk 15 kilometers when you're pregnant, unnecessary. This is a classic information gap story. And when you do reach the healthcare center, you end up with a huge long queue, limited resources, the doctors are overburdened, there's limited resource in the system. So it's a system optimization game again. So we said, how can the Asha worker become much more than just empathetic advice and some contextual understanding? How can they actually be empowered with tools, with data, with decision making, so that the patients have choices to make and they can address more critical issues? And one interesting area that we discovered was around this notion of knowing like basic diagnostics from things like oxygen flow rates in your bloodstream, pulse rate, heart rate, all the simple statistics. And what we learned was that the WHO recommendations, actually, you can build on their algorithms and do some nifty stuff on top of it. So, like, why not? So what we did was we built a catalog of low-cost tools that enable data to flow in the system through cheap cell phones, through simple devices. And I'll show you the simplest of all the devices that we built. This is too simple, actually.
This is the demo of the clock app converted into a pulse oximeter. So let's switch it on. It's ready. You need to set the needle at the start position. And you place your thumb on the sensor. And you can set the read button. It goes and it's reading.
Simple traffic light model, basic science. And then the next step was, of course, to take a picture of this thing on a phone and send it for an image processing side. That was the dream. And we built a pretty interesting story around that. We tried to sell it to the government, but the government wasn't very interested because they were kind of had different agenda. But then we started doing our own, let's call it renegade pilots here and there, and we started getting traction on this. So super different story, completely different universe of data crunching. And yes, cloud computing comes in the picture too. For those of you getting nervous that there's no cloud here, yeah. So yeah, you convert an alarm clock because this gadget has a buzzer, it's got a motor, it's got a battery management system, it works off a single AA cell, it's got an enclosure, you name it, it's got like everything. It doesn't have a microprocessor. So we just got a cheap microprocessor and we did the rest. Yes, now comes a big agenda for us. So, like I'm a bit tired of trying to convince large companies that they should look at problems differently. So at some point, I said, come on, let's do something on our own. Let's pick some big agenda and let's go with it and see if we can build some sophisticated stuff that actually changes the way we perceive our environment, our society, and do something interesting. So a couple of years ago, I sort of made a conscious choice. Let's completely do our bread and butter business. Let's keep it alive. But let's start investing in new ideas that would actually do something fundamental. This is an interesting passion for me off late for the last few years. Air quality, as you probably know, now that we are in London, is sometimes a challenge. But it's not limited to here. It's a global problem, right? WHO has all these crazy statistics. If you read some of those, you just get like scared. And it's an annoyingly big problem. And I can feel this because I grew up as a kid in India. I lived in urban and rural places. And every time nowadays I visit back home to visit my parents, I can feel this issue going exponentially to a point where I'm getting nervous now because it's actually a staggering problem. And then we discovered that it's not just in so-called developing countries, it's a problem in many places, even in the most advanced places in the world, because there are certain types of emissions and certain types of issues which go unrecognized. Even if you have electric cars running around all over London, you will still have problems with particulates. You will still have problems with other types of issues. So how do you create social pressure? How do you create movement in this system? How do you create a bottom-up approach was the first question. And then we discovered there's actually a business case also hidden somewhere in there. The European Commission has all kinds of interesting facts on, scarily interesting facts on how much impact healthcare it has and how much state budgets are going into because of bad air quality and all that stuff. The primary pollutants are NO2 and NO, there's NOx, this deadly combination with ozone, which affects our nervous system, affects our brain function, affects a lot of stuff that we don't even realize. There's also fine particles which go through your respiratory system and that your respiratory system cannot filter and they go in your bloodstream eventually. Extremely carcinogenic. Battery. Sorry. I love more gadgets. Hello, can you hear me? Okay. So how is this measured and how do people monitor this? How do governments enforce all this stuff? It's traditionally done through these huge container-sized things, which have a lot of scientific instrumentation inside. It's powered with the mains grid. It's got air conditioning. It's got all the stuff. And then there's a constellation of scientists and consultants and all sorts of companies doing analytics, basically by downloading data and then running some spreadsheet rules and then producing reports after reports. And they're all retroactive. You get annual reports. You get quarterly reports, whatever. You cannot take action on those things at all. So we were wondering, what can be done about this? How can we create a societal momentum in this? How can we do something interesting in this space? So the original intent was to create something affordable, something that we can reach out with, something that will create new social dynamic around this. And then we discovered there's actually a business opportunity there too. So what we did was that we, instead of having such a huge device, which costed enormous amounts of money, typically 200 to 500,000 euros capex cost, and then huge operational costs. This is a classic one in Copenhagen. There's one over here in Jose Allensen's Boulevard. And we went to the city of Copenhagen and said, do you want an alternate strategy? I said, yes. So we started working with them. And we did something nifty. So we said, let's do a subscription service where we deploy relatively low cost, more affordable sensors as a grid across the whole city and start building all kinds of learning algorithms on top, which will start running compensations, will be self-calibrating, will provide equitable data to everyone. We go street by street instead of just 2 measurements for the whole city. And we will get really localized data. You will get like hyperlocal data, and you will get actionable insights. So we built a solution called the Copenhagen Sense, rightfully so, because it was done in collaboration with the city of Copenhagen. And it's basically a little device that can be mounted onto a lamppost, has a whole array of sensors inside, And I'm not saying they're absolutely the best in the world, but they're reasonably good. And we have a compensation strategy for the reasonably good versus the best. They have electrochemical cells that measure common pollutants, gases. It has particle counters using laser diffraction. It's got the communication infrastructure. It's got a battery. It's got everything packaged in one. And it's almost like the pollution control industry simply didn't hear of this world of cloud infrastructure and sensors. I was a bit surprised because I was like, gosh, this is like a nice niche that no one has taken. So we're like, let's do it. So we spent almost 2 years building a product, a lot of steep learnings. It's hard to get a cheap sensor to produce good quality data, and we managed to crack that problem. And now we have a fantastic cloud infrastructure behind it that does the rest. It's a device that can be easily mounted. It's portable. We're doing a pilot soon here in London. It costs a fraction of that. And the most important thing is we're changing the business model. So we're not selling expensive instruments. We are selling sensing as a service to cities. So what we're doing is we take care of product deployment, networks, calibration, data backups, infrastructure, analytics, automated reporting, and producing real-time APIs, through standard RESTful interfaces, to a whole host of service providers, including bus companies, environmental agencies, you name it. So we are turning the business model upside down, and it's proving to be interesting. And then, of course, there's a cloud infrastructure where you can go in, log in through apps and stuff like that, see what's happening, export the data if you wish to, and work with some legacy tools like most government agencies do. Or you can be online and you can do real-time stuff with it. One of the most interesting things we're doing, at least in Copenhagen, is we're feeding data into what's called as intelligent traffic systems. So this means we can start optimizing traffic flow with traffic light control and stuff like that. Interesting experiment. The science part of it is pretty hard. It's really hard. We've been fighting this for quite some time, and now we're getting very close to getting very, very accurate results from this. We've been massaging the data science behind it, the sensor signal processing, and we're trying to get it to be almost as good as the really, really expensive stuff. But what we discovered was that this opportunity is not just limited to measuring some gases and particles. There's a whole host of stuff that's actually happening out there, which is ready to be platformized, ready to be servicized, and ready to be turned upside down in its business model. So we said, let's do a portfolio approach, and that's exactly what we're doing. And then someone came along and said, hey, look, the business case for this is pretty strong. It's a surprisingly large market that no one has shaken up yet because it's a boring B2G industrial use case that no one ever thought was glamorous. And now it's become a social issue. So we're doing noise. Similarly, we're doing noise monitoring in real time in cities. We're doing wind dynamics. Soon we're going to do pollen based on image recognition. You wouldn't believe it, pollen even today, even though the weather reports, they give you once a day some indication, actually is not real time at all. There's someone who actually takes a filter paper and puts it under a microscope and counts the number of pollen particles in it and then sends a number somewhere. Guess, is that ready for disruption? Maybe, yeah. And then we also scan how many people are exposed because of this. So we do Bluetooth and Wi-Fi scanning around it, and we start building. So now the business model is not about emissions. The business model is about your neighborhood and the data around it. And guess who's the single most worried about this? It's actually the real estate market. And it will have some interesting impact on that. So anyway, the summary of my story is that information to knowledge gap is a story question. If you can tell beautiful stories with that, you can easily transform information into knowledge, hopefully. The market dynamic situation, like there's a lot of need to have versus nice to have gap. And I think that's where the play is, which angle do you come in from? Are you coming in from need to have to the nice to have, or the other way around? And that's an important question to ask for yourself. And last but not least, of course, the product to ecosystem story. Business as usual doesn't make sense. So what's that new story? And my personal take on this is that you could, and people are doing this in very large amounts, take data as a tool for market differentiation. That's what almost every company is trying to do, right? But data can also be an enabler for new market creation, which is also an interesting fact, and there are some disruptions happening in that space. markets that didn't exist suddenly start getting formed, and then you start playing in that game. But the most important thing, I think, personally, is if you use data as a material for creating new types of behavior, then you create everything else around it automatically. So this is what we are trying to do. We're hoping to influence behavior. We're hoping to influence societal perception, and with data, with transparency, with action, and then automatically create, hopefully, an ecosystem of businesses around it. That's the short story. If you have any questions, you're welcome to ask.
Very good. Thank you, Vinay. We got a few minutes for a couple of questions. I just want to ask real quick, so if you are in a business today and you actually are collecting data, or is in the process of learning how do you get started with mining and finding useful insights for the data? Where do you start?
First thing I would say, build a heterogeneous lateral thinking team around the data. That would be my first take. Don't bring in all the usual analysts and the traditional data crunching type people. Bring in some data science guys, of course. It'll be nice to have them because they have really neat skills that's required for this. Bring in some social thinkers. Bring in some artists. Bring in some radical thinkers into the space. Throw them in a room for just a week together with some good food and wine, and give them a lot of data to play with. And make sure they have the tools to play with this. That's also the hard part, of course. The fluidity of the tools is really limiting today. Hopefully that'll change very soon. And magic comes out of that stuff. It's not the data that's the roadblock. It's the mindset with which you look at the data is the roadblock.
That's a good insight. Any questions from the audience? We good? Excellent. Thank you, Vinay.